All right, today we're going to be working on dividing monomials. So we're going to simplify expressions with the quotient of a monomial, or dividing monomials. And we're also going to simplify when we have negative exponents, and I'll show you what that means in a little bit here. So as we kind of alluded to yesterday, dividing monomials is very similar to multiplying monomials. When we multiplied the coefficients and added the exponents, so we're going to divide the coefficients, or in other words, reduce the fraction and subtract the exponents. So here's the exponents part, 15 and 7. We're going to subtract them and get 8. If there were numbers in front of these, we would kind of reduce that like a fraction or divide it evenly if it does. Let me show you. So here's an example. We have the x's and the y's. There's no coefficients, so we're not going to worry about those. So we just worry about subtracting these. So we do 7 minus 6 and 12 minus 3. Well, the 7 and the 6, 7 minus 6 and the 12 minus 3. 7 minus 6 is just the 1, so x to the first, and this is y to the ninth. Real simple. All right, here we have a to the third minus an a to the first. That's a squared. And then 7. So we have an a squared and a b to the seventh, so that is d. Just like multiplying, when we have a number on the outside like this, we do have to distribute it. Remember, these have a single exponent and they go to exponents. So this is going to be 5 cubed and 4 cubed and c cubed. We get cubed for all of these. Everything gets a cubed. And now we're going to multiply these together since they're both exponentials. And then we're going to have to just simplify these numbers. So 4 to the third is 64. 3 and 3 is 9. 2 and 3 is 6. And 5 to the third is 125. If we could reduce that, we would, but we can't. So then we need to know anything to the 0 power is 1. So no matter what's inside that parentheses, if it's to the 0 power, that equals 1. That is a definition we need in case when we subtract them that they cancel each other out, just so that we understand that. We'll have one of those in a little bit here. But first, anything to the 0 power, we don't even have to worry about what's on the inside because everything is going to make it just 1. So you could simplify this here, but the answer is still just going to be 1. Now here's one that we can simplify, m to the 0. That can just go away. We don't need that. N to the third and n squared. We're going to subtract those, and we just get an n to the first because 3 minus 2 is just 1. So again, this anything to the 0 power is just 1. Here, the x cancels out, and the k 5 minus 3 is just k squared. The other thing that we need to understand is a negative. If we subtract and we get a negative, which is a possibility, negatives go ahead and switch location, whether they're in the numerator, they go to the denominator, and if they're in the denominator, they go to the numerator. They're not happy where they are. They're negative. So we switch them to the other side. So if they're on top, we go to the bottom. If they're on the bottom, they go to the top. Most of the time, it's just going to be that we're going to move it to the denominator, but there are times that it does move up, just to be aware. Like this one here. So which ones are not happy? The negative ones are. So x to the negative fourth, that's not happy, so it's going to move down. The z to the sixth, that's not happy, it's going to move up. The y to the ninth, that's positive, so he's happy, he's going to stay where he's at. Now when you move them, they become happy because they're now in a new spot. So the z goes up, becomes happy, the x comes down and is happy, and that's my new answer. All right, here's one that we can work out completely. So we're going to start with worrying about our coefficients here. We are going to go ahead 75 over 15, and we are going to go ahead and reduce that. The p's will go ahead and put together, the p to the third and p to the fifth. Q, negative 5 and negative 4, and the r's, there's none up here, and negative 8. So now we're going to go ahead and subtract these. 3 minus 5, negative 5 minus a negative 4. Be careful about the double negatives. And the r to the negative 8 is just going to come up because it's really the 0 up here. So it's 0 minus 8, which is positive 8. Over here, we had 75 minus 15, or divided by 15, which is just 5. That gives us p to the negative 2, q to the negative 1, and r to the 8th. And remember, if they're negative, they're not happy, so they're going to move. Well, these are all considered in the numerator. So the negative ones are going to go down to the denominator, and we're going to be able to write our answer. So 5r to the 8th stays up, and the p squared q goes to the bottom. Simplifying this, we have negative 30 and negative 3. That's a fraction. We're going to have to simplify it the best we can. So that one's going to be simplified. We took the x's together, negative 6 and 4. The y's are 5 and negative 2, and the z's are 1 and 5. So we're going to subtract those. So this is just negative 1/10, so negative 1 with a 10. Negative 6 minus 4 is negative 10. 5 minus a negative 2 is positive 7. And 1 minus 5 is negative 4. So these negatives here are going to go down to the denominator. So they become x to the 10th and z to the 4th. The y to the 7th stays on top. So which ones are moving here? The a and the c. C goes to the top, a comes to the bottom, giving us this value here. 36 and 9, that gives us 4. Then I'm going to do the x's. 5 minus 4, which is 1. 8 minus 2, which is 6. And 3 minus 6 is negative 3. So the z is going to be in the denominator. We're going to have 4, 1, x to the first, and y to the 6th in the numerator. Here, negative 5 over negative 25 is 1/5. So 1/5 is a 1 on top and a 5 in the denominator. For the a's, negative 7 minus 1, so negative 8. Then we have 1 minus a negative 2, double negative, that makes a plus, so it's really 3. Same here with the 6, minus a negative 6, so that makes 12. So what's going in the denominator? That 5 from the fraction and the a to the 8th. 5 and a to the 8th, yeah, well, that's these. But then we need a 3 and a 12. B to and C 12. There we go. And that's what I have for you today.